for 4 variable k-map, we have already seen the k-map, that how it is being drawn. Next we will be taking the example, like 4 variables are there, a, b, c, d. If a, b, c, d is there and it is having the function like different mean terms are there, so 0, 1, 3, 5, 7, 8, 9, 11, 13 and 15. Suppose these are the different mean terms that is defining the function f. So to implement its k-map, we have to draw the k-map. So 4 variables are there, so we will be considering 2 variable a one side and 2 another side. So here suppose it is ab and here cd. So ab and cd, so it is 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Now if we talk about the mean terms, so it will be 0, 1, 2, 3, 4, 5, 6, 7, 8 will be here, 9, 10, 11, 12, 13, 14, 15. So once we have the given the mean terms, we can write it in this way. So 0 is available, so for 0 we will be making 1. 1, 3 is also there, 5 is here, 7 is here, 8 is here, 9, 11, 13 is here, 15 is here. Okay, so if we talk about the 4 variable k-map, there the procedure will be, in the procedure of 3 variable we have considered the octet, but in case of 4 variable, the procedure we will be taking is we will be starting with pairing of 16. So if we will be looking for pairing of 16, then we will be looking for octet, then a quad, then for a pair, then for a singleton. Okay, and then we will be reducing or identifying or removing the redundant term. So here looking for 16. So first of all we are looking for 16 pairing. So there are 16 squares, but 16 square pairing is not possible because all the squares are not having 1. Okay, so this is rejected. Now we will be searching for octet. So search for octet. So there is a possibility of octet. So here octet is possible. So we will be making 1 octet pairing. Now this has been done. Next look for a quad. Quad means pairing of 4. So is there any possibility of making the pairing of 4? Yes, there is a possibility. First of all, we will not considering this, like it is 1 pair. But these mean terms have already been considered by octet. So there is no need to consider again. But we can consider these mean terms if it is going to make octet or quad or pair next time. If with the help of any of the mean term, if we are able to make the quad, we will be considering this. But inside this quad we will not inside this octet we will not be considering this is an quad, because these mean terms have already been considered. But now we can just see like this one, 1 1 and this is 1 1. So there are 1 1 and 1 1. So okay, we can make a quad like that also. This is and this. So by considering these two and these two, so these two and these two will be considered adjacent to each other. Okay, so here this is a quad. So this way we can make the quad also. And if it is possible to make a quad by already considering the mean terms, then we will be proceeding to make the quad. Okay, but we cannot make the quad inside by taking the inside of the variables like minterms. If suppose one more extra ones are there, so then we will be making this as a quad, but we cannot make the quad here. Okay, so the minterms that already have been covered, we can take the help of them to make the quad or other pair or also, but all the minterms of the octet cannot be considered for the pairing or for the quad. So that have already been covered. Okay, so we will be minimizing, not selecting that. Okay, so this was we have already. So now we have made one quad and one octet, and with the help of one quad and one octet we are able to consider all the ones. Then now we will be writing the function. So with respect to the quad, we can just consider, so in between here, this one and this one, these two rows are being considered for quad. So in between these two, which one is common? So this 0 is common, 0 is common. So 0 means b bar is common. So in between this b bar is common, so we will be writing b bar dot. In these two are vertical lines or columns been considered for quad. So here 0 0 and 0 1 is there. So in between 0 0 and 0 1, which one is common? This 0 is common, and this 0 is common in both. So this 0 indicates c bar, so it will be b bar and c bar plus. Now we will be going with the octet. So in that octet we can see like in the vertical one, all all possibilities of AB is being considered. So if we add all these, it will be coming out to be 1 only. It was like A plus A bar is coming out to be 1. Similarly, if we add A bar B bar plus A bar B plus A B bar plus AB, if we add all this is not there. If we add this one, this 4 terms, it will be coming out to be 1. So if we add this one, it will be coming out to be 1. So 1 multiplied by the term because of here. So 1 multiplied by the common between these two. So in between these two, the second term is common, that is D. D is common, so it is D. So it is like B bar C bar plus D. So from the above, we can also see if we are able to make an octet, so octet will be reducing the 3 variables. So out of 4 variables, 3 have been reduced, only 1 is left for the 4 variable term. Okay, and also for 3 variable term, the 3 variables will be reduced. So 3 variables are reduced means only 1 is left. But in case of 4 variable term, if octet is there, it will be able to reduce 3 variables, only 1 variable is left. If a quad is there, if 4 variable case quad is there, that will be able to reduce 2 variables, only 2 variables will be left. Okay, so the final simplified one is B bar C bar plus D in case of 4 variable function is there. Okay, so this is how we need to do the minimization. And one more part we will consider is like, suppose we have the implementation with respect to the don't care also. Suppose we have a function ABC. We have not considered the don't care condition. So suppose we have a don't care condition, like suppose a function is defined by 0, 1, 5 and 6, and it is having a don't care condition like 3 and 4. So it will be summation of don't care. So in that case, it is having 3 variables. So for 3 variable, we will be considering the K-map. Okay, so the 0, this will be going to have 0, 1, this is 1, 2, 3, 4, 5 is here, 6 and 7, so 6 is here. Okay, so this was the 4 main terms, and these are 3 and 4 don't cares are there. So 0, 1, 2 and 3 is here, so this is don't care. 4, 4 is also there, so 4 we will consider. So don't care will be represented by x. So okay, to solve this type of cases, it is a bar a, b bar c bar, bc, b bar c, bc, bc bar. Okay, so now we will be again looking for octet. So there is no octet possible, so now octet is not possible. Now we will be going for quad. So we will be looking for quad, and in making octet, quad or pairing, we can consider don't care. Okay, so with respect to that, we will be looking for the octet. So now we can just see, like here we can make a quad. Quad means 4 adjacent squares pairing. So here one quad is possible, so we will be making the quad. So quad is possible, one quad is possible. The next we will be looking for a pair. So pair we will be doing. So pairing we can do. So here it is separate, but to make the pairing we can consider this, like from this and this. This is one pair. So pairing can be done this way also, and pairing can be done with the help of don't care. Okay, and now one thing, like this don't care have been left, and don't care is like it can be 0 or 1, so we need not to consider it if it is providing a separate term. If we will be providing this separately, it will be an extra term there in the function. Okay, so just consider all the ones have been considered. So now what is the function? So function will be with respect to that quad, a plus a bar, it will be 1 dot, in between these two common is there, that is b bar, plus in this case this is and this, so a dot in between these two, which one is common? C bar is common, so a into C bar. So this was without considering this. Okay, now without don't care, we can just consider like, so this is without don't care. So suppose with the don't care, so if we include this don't care, suppose we include this don't care, and this is, we have made the pairing like that. So if we include the don't care, in that case these two terms will be as it is. There will be an extra term because of this. So here it is a bar into common between these two is C. So it is coming out to be B bar plus AC bar plus A bar C. So this term is coming out to be extra term. It was not required because don't care doesn't affect the function. It is only the extra term, or it could be 0 or 1. It is not going to define the f. Okay, so to make the pairing, we will be considering don't care only if it is able to make an octet or quad or a pair to reduce the function. So we cannot consider don't care with another one if that particular one has already been considered. Okay, so this is an redundant one. So this is a redundant term. So we will be neglecting this redundant term. Okay, so I hope you have got the point. Now we will consider the case of product of sum forms also. So just take an example. So suppose a function is defined in terms of two variables. So it is given like a plus b, a bar plus b bar, a plus b bar, if this is the case. Okay, so now it is a two variable k map. So we will be drawing a two variable k map. So in that case, in sum of product case, it was 0 and 1. Okay, so it was 0 is explaining about a bar. So now in this case we have to consider a bar downside, and this is a, that means this 0 will be for a and a bar will be for 1. Okay, so similarly here also it is b and this will be b bar. So with respect to that, we can just see what we can write is a plus b. So a plus b is there. So in the sum of product we were doing is this dot this we are doing, but now we will be doing a plus b. So here a plus b is explaining this term. So this will be 0. Instead of ones, we will be making it a 0. So a plus b will be 0. So instead of 1 we were writing in sum of product terms, but now in product of sum we will be writing 1 instead of 0. 0 instead of 1. Okay. So it is a bar plus b bar. So a bar plus b bar is this one. So we will be writing 0. A plus b bar. So a plus b bar. So a plus b bar is this one. So we will be writing 0 here. Okay. So once we have drawn the K-map and filled the main terms, now we will be making the pairing. So the pairing concept is same. So whatever the possible pairing is there, we will be making either 4 or 2. So here 2 pairings are able to make. So the function, reduced function will be this one. So here a, this here only one term is there a, this is common between. So a plus b into b bar. So here we were adding, but here we will be multiplying. So it will be b plus b bar or b dot b bar multiplied by these two terms. So these two terms are like a, we were in between these two we were taking common or we were adding, but now if these two are included we will be multiplying a into a bar plus it will be added with this term, that is b bar. So we will simplify it. So it is b into b bar is equals to 0. So this will be 0 and this a into a bar will be 0, is it? So it is a plus 0 into this one is 0. So it is 0 plus b bar. So we can simplify it like a into b bar is there. That means the simplified function will be a into b bar. Okay, so I hope you have got the point. The next example we will see. So suppose we have a function given like in terms of max terms it is written 0, 2 and 3. So a and b only two variables are there. So with respect to that, so this is your a will be there, a bar, b, b bar. So it is 0 to 4 is there, that means the function will be 0 means here this will be indicating your 0. 0, 1, 2 and 3. So 1 is not included, 2 is included and 3 is included. Now we will be making the pairing. So pairing will be one pair here, another pair here. So with respect to one pairing, this one a dot a bar plus b, it will be multiplied by a bar plus these two terms, both terms are included means it will be b dot b bar. So it is, this one is 0, so it is b dot, this is 0 means a bar, it is a bar b. Okay, so similar we can go with the 3 variable case also. If we consider a 3 variable function, so suppose 3 variable function is defined by like not summation, it is product of max terms. So it is 0, 1, 3, 5 and 6. If this is the function, if we want to go with 3 variable k map. Okay, so here it is A and this is equal to B. So it is, this will be A and this will be A bar. Now while writing the B bar terms, so the here it will be B plus C. Next one is B plus C. Initially it was 0 1. So if it is 1 is there, so for 1 it will be complemented. It was 1 1, so 1 1 was there, both will be complemented. In case of sum of product terms, it was 0 1 0. So 1 0 means 1 and 0. 1 means complemented, so this one will be complemented. So it is going to explain 0 0 0 1 1 1 1 0. So 0 means A, 1 means A bar. So this is, we have already seen in case of this product of some terms. So here 0 will be indicating A and 1 will be indicating A bar. Okay, so this is how we have retained the K map. Now we have to fill the data, fill the mean terms. So these mean terms are 0 1. So here again that will be there 0 1 2 and 3. So 0 1 2 3 4 5 6 and 7. So we need to fill 0 1 3 5 and 6. So 5 and 6. Okay, so I hope you have got the point. Now we need to make the pairing. So first of all we will looking for octet. There is no octet. Now we will be looking for quad. There is no possibility of quad also. Now we will start with pairing. So there is the pairing. So we should be making the pairing so that all the zeros can be considered. So to consider this 0, this way there is no 0, so we have to make the pairing here also, here only. For this considering, we have to make the pair this way also, and for including this we have to make the pairing here, and for this 0 we are not able to make any pairing either way, so we will be leaving as it is, so only one terms. The function now will be given by like this one is there, so A is there, so A plus in between these two whatever is the common, so in between these two the common is or common that we will be depicting is like B is common, so it will be B. Okay, I hope you have got the point. Or if you don't want to go with the shortcut, you can just see like we have to multiply these two. That means if this is, we are considering this term and this term will be multiplied, so B plus C multiplied with B plus C bar. So if we expand it further, so it is B into B will be B only, so it is B C bar plus C B bar plus C into C bar is equals to 0. Okay, so from there we can just simplify it further. You can just see in between these two B is common, so B plus B is common, C plus C bar, so C plus C bar is 1, so it is B plus B, again it is coming out to be B, so B has been written. So this is, after simplifying it you will be getting the B only, but the overall the idea is in between these two which one is common, so B plus C, B plus C bar, in between these B bar is B is common, so we will be taking B. Now consider the second term, so suppose take this one, so it is A in between this one and this one, which one is common, so C bar is common, so it will be A plus C bar. Now consider this pair. For this pair, A into A bar plus B plus C bar. Okay, B plus C bar. For this we have to write like A bar plus this both will be considered like b bar plus c. So now we can just write like a plus b, a plus c bar. This is 0, so it will become b plus c bar. Here it will be a bar plus b bar plus c. Three different terms will be there. So this is the simplified one in case of 3 variable case. Okay, so similar we can do the 4 variable case also. Okay, so I hope you have got the point, like how we are doing the simplification. And one more we can just see is 5 variable. So with the help of K-map, up to 4 variable we can do easily, but up to 5 variable we can do. Okay, so for 5 variable the K-map is defined by like, so for 4 variable we have already seen the K-map. That means suppose 5 variables are, any function is there, a, b, c, d and e, and that is having some mean terms. Okay, so its K-map is defined by like this. It is having two mean term, 16 squares mean terms. Okay, so this was the MSB and this is LSB. So whatever is the MSB or either of the term you can take. So suppose this one is indicating A and this is indicating B bar, sorry, A bar. Then we have to consider BC here, DE here, BC here, DE here. So for different BC combinations, it is 0, 0, 0, 1, 1, 1, 1, 0. For different DE combinations, 0, 0, 0, 1, 1, 1, 1, 0. So same is here. So it is 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Okay. So if A, it is representing A, or we can call it A is equals to here. Sorry, we can write like here A bar, and this way we can write A. So if A bar, it is representing this block, this 16 blocks are representing the A bar, then it is representing the 0, like, so it is 0. So here this is A, that means it is representing 1. Okay, so if this, for all this 16 blocks are there, 16 squares are there, that means for all it is 0, A is 0. Okay, so if 5 variables are there, A, B, C, D, E, so the different combinations will be 2 to the power 5, that means 32 possible combinations will be there between A, B, C, D. So if A is 0, 16 possible combinations will be there. If A is 1, 16 possible combinations will be there. So we have separated it out like this 16 representing for A equals to 0 and this 16 represents A equals to 1. So total overall 32 we have got. Now we need to proceed with the example. So this was the case, like we are considering the 5 variable case. Now take an example of 5 variable case. So suppose the example we will be taking like, in that, suppose this is defined by the variables like 0, 2, 4, 6, 9, 13, 21, 21, 23, 25, 29 and 31. Suppose these are the different mean terms in this case. So different mean terms will be defined like, here it will be 0, this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This will be 12, 13, 14 and 15, and then after 15 16 will be here. So this will be explaining the 16 because a is 1 and all others are 0, so it will be explaining 16. Then this is 17, 18, 19, 20, 21, 22, 23. This is 24, 25, 26, 27, 28, 29, 30 and 31. So this was the KMF for 5 variables. So in between that, now we have the mean terms. We will be placing the mean terms. So now 0. For 0, we will be placing 1. For 2, 2 is here. 4, 4 is here. 6, 9, 9, 9, 9, 13, 21, 21. This one is 21, 23, 25. Yes, 25 is here. 29 is here. 31 is here. Okay, so we have placed all the mean terms. Now we need to do the pairing. So pairing starts with, here we will be starting with 32 pair. So 32 pair is, there is no 32 pairing is there. Now we will be going with 16. 16 is also not possible. Now we will go with 8. 8 is also not looking like here. Now we will go with 4, that is quad. So quad is possible. So quad, one quad is able to here. We will be able to form here one quad. Another quad we can just form is like this one. Okay, now there is no further quad we can form. And now after quad we have to make, yeah, one, once we have done the quad, now one quad we can further include is like, we can consider this one. If we superimpose this all 16 over here, this and this can make a quad. But even if we are not able to make the quad, then also we can simplify it. We can simplify it with the help of pairs also. Suppose this is one pair and this is another pair. So with respect to that, we will be writing the expression. Okay. So the function will be, this is a one quad. So in between these two, common is b bar. So b bar is common. So first of all, it is a bar. This is explained for a bar. So a bar into b bar. B bar is common. In between these two, 0, 0, 1, 0, e bar is common. Okay. Plus, if we consider this quad, so here common is c. So it is defined for a into c. It is a into c. Okay. Multiplied by these two common. In between these two common is there, that is e. E is common. Now the next term is, if we consider only this, it will be a bar into, in between these two common is b. In between these two, b was common, and here it is d bar e. D bar e. Next one is, we can consider this one. For this one, it is a. In between these two common is b into, in between these two it is only d bar e. So just consider these two terms. So in between these two terms we can just see b d bar e is common, then it will be a bar plus a. So a bar plus a will be 1, so it will be resulting into b d bar into e. That means it is nothing but this and this are going to make a quad. So if it is going to make a quad, this term will be coming out. We can make a quad out of this, or we can separately consider these two, and then result will be same. So it is coming out to be a bar, b bar, e bar plus ace plus b d bar e. So this is for the 5 variable function. This is how we can simplify it. Okay, so up to here we have considered the minimization of 2, 3, 4 and 5 variable function. But before going for minimization, we need to make sure our function, suppose a function is there of 2 variable, so a comma b, 2 variables are there. It is written like ab plus suppose it is written a bar b plus a, if this is the function is written. So we cannot go with minimization of this, or suppose we have done the key map. What are the different mean terms are there? We are not able to depict what are the different mean terms that we should be representing here in the key map. So whatever the function is written, first of all we have to reduce this, or first of all we have to expand this function such that it should be written in its mean terms form. Okay, then only we can proceed with the putting the mean terms into the k map. So whatever the function is given, first of all we have to convert the function into in its respective mean terms. Okay, then only we will be able to put the function into the expression for minimization. Suppose we have a function that is defined by like ab plus bc plus ac. This is the function of 3 different variables. So if we want to proceed, we can't directly put into the k map. That means if this is the k map for 3 variable, so where ab should be there, we are not able to put. So we have to, that means this is in standard form. This is in standard form. But to represent the function into the k map, we have to convert to the canonical form. Canonical form means the function should be written in its mean terms format or max term. So if it is in mean term or max term, then only we will be able to put the values mean term or max term into the k map. So before proceeding with the solving the function or the minimizing the function using the k map, we have to convert the function into its canonical form. Okay, so here to convert this function into canonical form, that is ab plus bc plus ac, we have to write like each term should be constituting all the variables. So there are 3 variables, so each term should be written in its all the 3 variables. That will be your canonical form. So to write that, so first term c is missing, so we will be writing like we will be multiplying by the term c into c bar. We have already seen this. Okay, so now it can c plus c bar is 1, so ab multiplied by 1 will be not affecting any not doing any effect on the function. Okay, similarly in bc, a is missing, a term is missing, so a plus a bar we will be multiplying into bc. Similarly ac is missing the b term, so a b plus b bar into c, we will be multiplying with this term. Now we will be expanding it, so it will become abc plus abc bar plus abc a bar bc. Now abc ab bar c. So now we can see abc abc abc, which is 3 times, so we can write for one time a bar c, a b c bar, a b c bar, no, there is no further repetition, a bar bc, a bar bc is not repeated again, it is a b bar c. A, B bar, C. So now you can just see the function is written in different mean terms, that is constituting all the three variables. So now it is in canonical form. So if it is in canonical form, we can write it in respective mean terms. So it is like A, B, C is there, so it is 1, 1, 1. A, B, C bar is there, 1, 1, 0. A, B, C means 0, 1, 1. A, B bar, C, 1, 0, 1 is there. So this is M7, M6, M3, M5. Now we can write like in mean terms it is 3, 5, 6 and 7. If this is there, now we can proceed with the mean terms. So this is 0, 1, 2, 3, 4, 5, 6, 7. So now 3, 5, 6, 7. So 3, 5, 6, 7. So now we can proceed with the solving. Okay. So now we can do the pairing. So this is one pair, this is another pair, and this is another pair. With respect to that, whatever the function will be there, we will be writing it. So the function will be nothing but this only, means it was the simplified one. Okay. But this is how we should be proceeding. Okay. So before proceeding, we should be writing the function into canonical form, then only we will be proceeding to solve with the help of K-map. So this is all about the K-map, and with the help of K-map we can minimize the functions.